All right, let's take a look at equations for exponentials with and without shifted asymptotes. So what that looks like is you have a couple of grids like this, or exponential curves. A standard exponential curve looks like that, and you'll notice I'm adding a blue asymptote across at y equals 0. Then a shifted asymptote graph would be one with the asymptote shifted above the y equals 0. So that is that position right there. This is what we're going to get into. So exponentials without shifted asymptotes is what we've been doing, which is where we have been building tables with x and y columns to make that happen. Then the next step is we calculate a multiplier, and we've been doing next divided by previous. And if the numbers are consecutive, we have the multiplier and you're done. But if there's a gap or a jump in between the numbers in your table, then you have to do the gap root of next divided by previous. And of course, we know our equations are going to look like these, with the y equals a times b to the x of what it starts at and what it goes by. Starts at is the a value, goes by as the multiplier or the b value, and we're off and running. Now, let's go ahead and try one. We've done these before. Let's say we have our ordered pair points are 1, 6, and 4, 20, 25. As we just got through saying, we table it right away. That's step 1, build your table. And so you'll notice we put the 1 and 6, and then the 4 and 20.25. Then we make that calculation of next divided by previous. And again, in this example, there is a gap. So then we're going to need the gap root. And so the gap root to calculate the proper b value is we do the third root. So the third root of next divided by previous, that's where that 3 comes from. And you have to make sure that you do the next over previous. And this one was further down our table. So that's the next. Then we calculate the b value by doing this on our calculator using the math 5 button. So we'd go 3 math 5 of these two divided, and we get 1.5. That means it's 1.5 times larger each time. So if we look in our table, it grows by 1.5, and then again by 1.5, and again by 1.5 to get that 20.25. So we've worked our way down the table. Let's work our way back, because the ever important 0 number is the one that we need to get the a value. So when we do that, we divide the 6 by 1.5, because that's what it was multiplying by. We get the 4, and then that's what it starts at. We can clearly see that's the starts at number. And then that's what it goes by, or the multiplier is times 1.5. So putting that together, we get the equation y equals 4 times 1.5 to the x power. We should be very familiar with those. Now, let's look at the graph and pick up some of the details here. Noticing that as you look at this graph, you should see that it is the exponential curve. Of course, it starts low and slow and takes off. We see that happening. And then we also notice that it hits at 0, 4. That was the same information we had in the table. And then the asymptote down here is at y equals 0, and that's pretty standard stuff. It starts down here close to 0, and then it goes further away as you get further on the x inputs. Okay, now what if the asymptote is not at y equals 0? Then we call it a shifted asymptote, as in it's shifted away from 0 and it's up the graph somewhere. So those we're going to do very similar 3-step process. We're going to build your table of values. You're going to organize your data, but you're going to remove the values from the asymptote, from the coordinates, so that you can then do the proper math, because then you can calculate the next divided by previous. If the numbers in the table are consecutive, you have the multiplier. If there's a gap, you're going to do the gap root again of next divided by previous. And then finally, you'll put it together of what it starts at, what it goes by, but you will have the constant or the plus k at the end. And we'll talk about where that comes from. That's basically your asymptote number, because all of the values then are plus k. They're all shifted up. They're all added on extra by this k value. So we take that out momentarily, and then we run our numbers to build this part, which you're used to, and then we just stick it back on the end. So here's what it looks like. Every time you have one that has a shifted asymptote, they have to tell you what it is, or there has to be some clues in the story. Like it could be a real life story where they say the room temperature is 70 degrees. Well, then you'd have an asymptote at 70. In this particular case, they say the asymptote's at 7. So we're going to use these numbers with an asymptote at 7. So we build our table, because that's what we always do. So 2 is 16, 3 is 20, 25. That's our XY table. But we have an asymptote, so we have to make a third column. And we have to actually remove the extra 7, because we have an asymptote here at 7, we have to remove the value of the asymptote from the data so that you can properly use next divided by previous. Because each of these numbers are inflated by 7. They have an extra 7 added in them, so we subtract it out so that we just figure out what it's multiplied by to get there. So we'll do next divided by previous in this case. And for this one, we don't even have to do a gap root or anything because these are in order. So then you'll notice the values are the values we use for next divided by previous. And we ignore this center column. This center column gets crossed out. We do not pay attention or use those numbers anymore as we're building our equation from these numbers here. So let's calculate the b value. We no longer use the middle column. We're going to use the third column. So we do next divided by previous of 13.5 divided by 9, and that's going to give us 1.5. So our multiplier is 1.5 in this example, and so I know it's timesing by 1.5 each time. Then I divide, go back. I can fill that in with a 6 right here, and then I can fill that in again, and it also happens to be 4 in this example as well. Now this column starts at 4 and it times is by 1.5 each time. This is the column we use. We don't use this column in the middle. We use this last column, the y minus 7 column. It starts at 4 and it times is by 1.5, so we start having an equation like this. Then the y minus 7 column is the information we took it from. So what we need to do is then move the minus 7 to the other side by adding 7. So we're going to go ahead and cancel those out on this side, bringing them over here to this side. And we've got now our full equation of y equals 4 times 1.5 to the x plus 7. And that would be the correct equation. Now, I want you to look back up here and I want you to now let's understand this equation. Like, what does this equation mean? What are the values? Well, this equation represents all the data points in the y column. We just temporarily ignored the value so we could calculate or build the equation. This is where your answers live. These are not your answers. This was just the work over here. Your table would go 0, 11, 113, 216, and so on, because if you remember our original data points were 216, then these are our data points that we have in our table that actually work in the equation. All right, let's look at the graph of this. You'll notice that it has an asymptote at y equals 7. So if we take a look at the graph, notice it's still an exponential curve, has the same shape. You'll notice the curve starts at 0, 11 because it had an extra 7 added on to every value. So it's up here. Then you also notice that the asymptote is at 7, and then it starts at 0, 11, and it's that curve kind of shape. All right, so here is your flow chart. Is it shifted or not? Then you table it. Then you do next divided by previous. Then you find the a value. Then you build your equation. So here it is with the details. Decide if the information has a shifted asymptote or not. It pretty much has to tell you in the problem. Then you're going to make a table is coming next. You either build a 2-column table if there's no shifted asymptote or a 3-column table if there is. Then you make your calculation of next divided by previous. Sometimes you need the hint where you have to take the gap root if it's a skip in values. Then you continue the pattern in the table to get what's across from 0, because the 0 value is the a, and the a is across from 0. That's your initial value of what it starts at. And then your equation is either going to look like y equals a times b to the x if it has no shifted asymptote, or it's going to be a times b to the x plus k if it is shifted up the graph. Now, I'd like you to try these 2 example problems here. They're one of each type. Then you'll be submitting your answers to show that you know what you've been doing on these.